Creator Allah. Welcome to Provision. In this video, we are going to explore amazing short circuit protection and other features of a made in Pakistan hybrid UPS inverter. I am your host Suhail Ahmad Zia. Following AC output short circuits on this 600 watt UPS are with light load a 60 watt lamp. Switch on, short circuit 1, reset, short circuit 2, reset, short circuit 3, reset, switch off. Output short circuits while heavy loads are present is more damaging on power MOSFETs. So our second set of AC output short circuits is with nearly maximum specified load of 510 watts, which is 500 watt tubular lamp, which is usually 450 watt plus a 60 watt bulb. Switch on. Short circuit 1, reset, short circuit 2, reset, short circuit 3, reset, switch off. Now let us cross limits. Before this demonstration, the overload trim pot was intentionally set by me beyond specifications for overloading of about 960 watts of real load. So this output short circuit shall exceed limits with the addition of one more halogen lamp. Switch on. Short circuit 1, reset, short circuit 2, reset, short circuit 3, reset, switch off. Let us look inside this UPS. For demonstration, it has been built in a scrapped, commonly imported UPS casing. Showing you inside. The size and board connectors are made compatible with most commonly imported UPSs. It shows that this board can also be replaced for irreparable boards in many imported UPS and inverters. Showing you the local and imported boards. For size matching, comparing both boards back to back. You can also place this board in a suitable casing of your choice. This is a sample made for local casing. Placing the board inside on its mountings. This motherboard has been assembled on a single copper layer printed circuit board, acronym PCB. Its size is 8.2 inch by 7.1 inch, showing the bare PCB both sides. There are no provisions for surface mount devices, namely SMDs, on this PCB. All intended parts are through-hole components, also called insertion mount devices. That is to say, it is an IMD design. For the sake of easy handling by domestic technicians. If required, any IMD PCB design can usually be converted into a SMD layout. Its controller card is on a single copper layer PCB, 1.9 inch by 2 inch in size, with a 16-pin connector to the motherboard. The controller card has been made and tested in both IMD and SMD versions. Showing IMD version, and showing SMD version. As you see, the motherboard is relatively high frequency inverter board. Nominal chopper frequency for step up inverter and step down charger is of the order of 30 kHz. The outputs of these high frequency inverters are then converted to 50 Hz to 30 volt AC output and 12 volt battery charging DC current respectively. The 50 Hz AC output is made by this third inverter, which is transformerless, and the battery charging DC current is produced by these Schottky rectifiers. The charger is capacitive coupled half bridge, unlike the flyback in commonly imported UPSs of this type. This is in order to have better utilization of transformer, simplify transformer design, and to relieve flyback high voltage stresses on the power MOSFETs by lowering the maximum drain source voltages, thereby reducing warranty cost. The design can be configured for other AC output voltage standards like 120 volt 60 Hz, other battery voltages and output powers. On 12 volt battery, it has been typically made for producing 600 watts of real power or more. depending upon the step-up inverter transformer and power MOSFETs. Its peak pulse power can be regarded as 1000 VA. This 600 watts UPS is made for 4 fans, average 100 watt each, and 4 energy saver lights, average 25 watt each. Again switching on UPS and removing extra bright halogen lamps so that we can see the output waveform on oscilloscope. Switching the oscilloscope on. Its output is step sine wave shape. It is like the commonly imported inverter, but crest factor, unlike the imported inverter, is fixed at 0.7. This is in order to have better peak and RMS equivalence with sine wave and to keep AC motors cool. Whereas the commonly imported inverters increase crest factor in order to have increased power and showing pleasing voltmeter readings with discharging battery voltage or an increase in load. AC to battery changeover voltage can be set by Zener diodes for 2 values by a selector switch from under 90 volt AC to over 190 volt AC at 50 Hz or respective voltages for 60 Hz standards when required. It also incorporates a high voltage AC mains protection set at 255 volt AC, or it can be adjusted to a different value as desired by Zener diodes. The automatic charger in this UPS is constant current type to make fast charging possible without damaging the battery. The charger prevents overcharging and overheating of the battery with an intelligent float boost cycle. This ensures long battery life and prevents sudden death of battery. The charger can be set for 2 current values by a selector switch as desired. The 2 values from 5 amperes to 20 amperes. Automatic protection against accidental application to 24 volt battery is also provided in the firmware programming. Battery low protection with microcontroller controlled compensation caters battery cable variations, battery size variations and load changes. This is in order to ensure full use of battery charging and simultaneously preventing over discharge to avoid sulfation in the lead acid battery. This UPS has complete means to battery isolation for layman user and children's safety. It has a committed neutral between AC input and AC output to suit a local wiring pattern. Uncommitted neutral is also possible with a change in PCB layout. Pages: linkedin.com/pub/sohain-zia-zia/.